So today I'll be presenting on the development of a real-time boom sprayer system for site-specific application of herbicides as well as insecticides. And this is my PhD research conducting here at DAL. And of course, my supervisor is Ahmad, a professor here at DAL University. Yeah, so just to highlight what farmers currently do in most countries, whether developing or undeveloped countries. Farmers tend to over-apply chemicals or apply what we call blanket spray on different crops. And this prompts the need to be able to explore various options that are available to reduce inputs. And at the moment, the technology allows us to be able to create prescription maps and later on be able to apply what we call variable rate application. So my research is taking that step further to be able to detect insects or weeds in different crop fields or different under different crop characteristics, and detect these in real time and be able to respond based on what has been detected and spray in real time as well. So the key components of the boom sprayer system, of course, you have the tank where you look at the volume that you require, the materials, as well as the features, whether you have buffers or also incorporate things like agitation to ensure that your chemicals are mixed effectively. Then you have a pump that pretty much drives the fluid throughout the entire system. And under this, you're looking at the size, the type of a pump that you're using, how much pressure do you need, the flow rate that you desire, as well as the head, looking at how big your boom might be. Then you could also look at the pipes that eventually deliver the fluid to the valves. So under this, you'll be looking to regulate your pressure because you want to be able to keep that consistent throughout your entire operation. So at the moment, I've been able to control the valves, and this is pretty much what my research has focused on at the moment. So different integration as well with other systems such as GPS, as well as speed of a tractor, because always affect when we intend to spray. I've also been looking at different valves and nozzles. At the moment, I'm looking at two different sets of valves, one of which is PWM, which is a technology that's renowned at the moment. And the other one is just the plunger valve, which just opens and closes based on the commands that you send. Then I'm also looking at different spray patterns. So if you're spraying insects or you're spraying weeds, the spray pattern is different depending on whether you're using contact as well as systemic herbicides. And I've also gone a step further to be able to evaluate what happens when the fluid leaves the nozzles. So you're going to look at things like temperature, how does that affect your drift, or things like wind speed, how are you going to tackle problems associated with that as well. And of course, the power requirements are things that I need to consider in my research as well. So this is our lab setup. This is the indoor development. So we have the valve control unit, and it has a microprocessor, which we're able to access using microprocessors such as Arduinos, and we're able to send commands to be able to control the nozzles based on what we've programmed, and we can actually simulate detection under this setup, and we're able to spray based on what we have detected. So each nozzle, we have a set of 6 nozzles, and each nozzle amongst these is able to be controlled individually, and you're able to change the nozzles as well as the valves just to be able to evaluate the things like pressure as well as flow rate in the lab. So eventually what you want to do is test the developed system on a commercially developed sprayer. So we're outsourcing our cameras for the machine vision system from a private company, and their detection is what pretty much detects or determines what we do downstream. So whether they've detected a beetle or they've detected weeds, my research now intends to be able to apply based on what has been detected. So if maybe they've detected a cluster of beetles, I might spray a bit more. If they've detected just one beetle, it's just a simple squirt, and I'll be able to address that based on what they're sending. And this is pretty much real time. So after detection happens, so the distance from the camera to the nozzles is also is calibrated in the field based on the speed of detection and the processing of data between the machine vision node as well as the entire valve node. So, and at the moment, this is pretty much what I'm doing in the field. I'm collecting data for different variable or different occurrence of pests in the field, so I can determine how best I can optimize the spray. So the significance of this research, we've got direct impacts from input savings because we'll be applying site-specific quantities. So if we're looking at a commercial scale, the savings could actually be substantial, and also be able to enhance the efficacy of herbicides as well as insecticides because we'll be avoiding co-application. At the moment, what farmers do, the current practice is a mix. The fungicides, the herbicide, and insecticides all put in one tank and just spray as a blanket. So we want to be able to develop a parallel system with a separate tank where we're able to spray the herbicides and insecticides in a totally different operation. Then also, this also addresses SDG 12, which is the Sustainable Development Goal related to responsible consumption as well as production, and it encourages sustainable use of different chemicals. And yeah, that brings me to the end of my presentation. Thank you.